As promised, I'm going to do a little review of factoring in case you forgot factoring or are rusty on what it's all about, because you're going to need to be able to factor in this class. So looking at the first example that we did in inequality, I'm just going to concentrate on the factoring now. We have to make sure that our polynomial is written in terms of descending exponents, which it is x squared x, and then no x there, or x to the 0 power. And the method that I like to use is a box method. You might have other methods. If you have other methods you learned that you're comfortable with, no need to learn this. Stick with what you know and practice it up. But in case you're starting from nothing here and you're looking for a method, I tend to like this one. So if we look at the box here, we notice the box has 1, 2, 3, 4 squares. We have a trinomial here, 1, 2, just 3 pieces of information. So we're going to need more information. But to get started, we're going to take this and put it in the first box. And then we're going to put this plus 5 in the last box. So this guy goes there, this guy goes here. Now, for this 16x, we have 2 boxes. So what we're going to do now is look at the process to how we're going to take this 16x and bust it up into 2 pieces. So what we do is we take this, the coefficients here that we have, 3 times 5 is 15. And then we look at this middle number, 16, and that's going to sit over here. We're going to look for factors of 15, so numbers that multiply to give us 15 and add to give us 16. So some of you might see this right away. Others you might have to go through some trial and error. So let's start with the obvious. 3 times 5 is 15. Those are factors of 15. However, 3 plus 5 is 8. That's not the 16 that we need. So other factors of 15 would be 1 times 15, which is our 15. And 1 plus 15 is the 16 that we need, the positive 16, so that works. So this is going to be what we use. And now, since we're using it to replace 16x, we're going to stick variables behind it. So this is going to become 1x and 15x. So let's put them in the boxes here. We have 1x, and then we have 15x, and they're both positive. So if you want to put the positive signs in, you can, or you can leave them out to know that they're positive, your choice. So we have all 4 boxes filled in, and now what we're going to do is we're going to look for the greatest common factor going down and down. So between 3x squared and 15x, the 3 is in common. 3 can be divided by 3. 15 can be divided by 3. So we have the greatest common factor of the 3. And now x squared x, we have a greatest common factor of x. Now let's go down here. 1x and 5. There's no greatest common factor. This has an x, no x here. 1 and 5, there's nothing that both of them can be divided by other than 1. So when there's no greatest common factor that we can see, it's a 1. Now, here is our factor, 3x and 1. We need a sign, positive or negative, in between there. So what we do is we look to the sign of the box this 1 is sitting on top of. So because this is positive, that's positive, and there is our first factor. So let me write it down here, 3x plus 1. Now we're going to do greatest common factor again, but this time we're going to go in this direction. So 3x squared 1x. There's the coefficient, only thing in common is 1, x squared and x. Greatest common factor is x. And now 15x and 5. Greatest common factor is 5. Again, we need a plus or minus sign in between these two pieces of information. So we look to the box this 5 is closest to, and it is plus. So this is going to be x plus 5. Now this factor looks a little weird being written down like that. So let's rewrite it here, x plus 5. And those are the factors that we came up with when we did the example in terms of solving the inequality. Next example, again, our box has 4 squares. This 1, 2, 3 trinomial. So we can put in this and this. This goes in the first, this goes in the last. And again, we need to bust up this negative x. And remember, there's that invisible 1 there. So let's make our table to help organize our information. Again, the invisible 1. So 1 times negative 20 is negative 20. So we want numbers that multiply to give us negative 20, and then add to give us a negative 1. So we multiply the first and third coefficients, and then the middle guy, we want to add to that coefficient. So let's look at some numbers here. Factors of 20. Well, we could do 2 times 10. 2 times 10 is 20. Whoops, we got a positive 20. We want a negative 20. So let's make one of these negative. So let's do negative 2 times 10, and that gives us the negative 20. And let's add negative 2 plus 10 gives us positive 8. Well, that doesn't work. We want negative 1. Other factors, we could do 4 and 5. So let's do negative 4 times 5. That gives us negative 20. And then negative 4 plus 5 gives us positive 1. Close, but we need negative 1. So let's switch up the signs here. 4 and negative 5. 4 times negative 5 is negative 20. So that works. And then 4 plus negative 5 gives us the negative 1. So that's the pair we want. And again, since we're using this to replace our negative 1x, we need to put some x's here. So this is 4x and then negative 5x, because 4x minus 5x is our negative 1x. So let's put these in the boxes here. 4x and negative 5x. And now we do greatest common factor again, going down, going down. So between x squared and negative 5x, we have an x in common. Between 4x and negative 20, here we have 4 in common, because 4 divided by 4 is 1, 20 divided by 4 is 5. We're not worrying about the sign there. We're just looking for the number. We need a sign in between, so we look to the sign that the 4, in the box that the 4 is sitting on top of. This is positive 4x, so this is positive 4. So let's write this here, x plus 4. Now, let's do it again, greatest common factor, this time going across. X squared and 4x, greatest common factor is x. And now, 5x, negative 5x, and negative 20. Again, don't worry about the signs here, positive or negative. Just concentrate on the variables and the numbers. This 5 and this 20, they have the greatest common factor would be 5. This has the x, but no x here. So we're done. And we need the sign. Because the 5 is sitting in front of a box that has a negative, it's going to be negative 5. And again, it looks really weird written vertically, so it's x minus 5. And there are our two factors. Last example I want to do, we haven't done this one in terms of solving the inequality, but I want to take a look at it for factoring purposes. We have this polynomial here. Now if we look, 1, 2, 3, 4, we have 4 terms, and let's see if anything can be combined to make it 3 terms, x cubed, x squared, x, a constant. So there's nothing that can be put together, combined to be simplified, so all 4 terms stand. So we can put them all in the box then. X cubed, 3x squared, minus x, and minus 3. And as before, greatest common factor going down. X cubed and x is x squared. 3x squared and 3, that would be 3. And now we have, whoops, this is not x squared, this is just x. My bad, my mistake. X cubed and x, greatest common factor, is just x, not x squared. Here, 3x squared and negative 3, the greatest common factor is 3. So at least I got that one right. So here we have x plus 3. Now we do greatest common factor going across. X cubed and 3x squared. This is where the greatest common factor would be x squared, because x cubed and this is x squared. So we can take out that x squared, versus here where it was just x to the first power. Coming across here, there's nothing that we see that's in common. So it's going to be 1. And again, we need the sign here. So we look to the box. This is in front of closest, and it's negative 1. So we have a factor of x squared minus 1. Because this is a quadratic, we can't factor this anymore, but this is a quadratic, x squared, and it happens to be the difference, subtraction here. So x squared minus 1, and 1 is a perfect square. So this can be factored again, x plus 1, x minus 1. And so for this, we have 3 factors because we started with a polynomial that was cubed.